Here are your solutions to simplifying rationals. Step one is to factor. So the numerator, I'm going to draw a diamond. Two numbers that multiply to 48, and because it's positive, they add, so it's going to be 6 and 8, and both numbers are negative. The denominator, you could also do a diamond, if you wanted to, with a 0, and recognize it's negative 8 and positive 8. The restrictions here, it's y. Look at the denominator. It's positive and negative 8. Both those numbers would make a 0 in the denominator. Cross out the common factor, and then you have your answer. All right, we're going to do this again. Number 2, we're going to factor. So the biggest number that goes into 12 and 30 is 6. And they have at least 3 W's. So 6W3. You can reverse distribute this. So 6W3 times what is 12W to the 4. Same thing here. We can reverse it. That's 5. In the denominator, the biggest number that goes into 16 and 40 is 8W. And then multiply, and that would give you 2W plus 5. So at this step, I'm going to write down what W can't equal. 8W, because it has a variable there, it can't be 0 because 8 times 0 is 0, and 0 times anything would be undefined. Here, reverse this. So if you have a number in front, make it a fraction. So slide that number back into the denominator and make sure it's the opposite number. And it's negative 5 over 2. Now we can cross out. W makes W to the 3 into W squared. The number that goes into 6 and 8.
Attention Robin students and staff. At this time, please release all seniors to the gym for a senior meeting with Johnston. Seniors should take their belongings with them to the gym. They will be released to 8th period at the conclusion of the meeting. Teachers who have all seniors in their 7th period class will escort their classes to the gym and remain in the gym to help with supervision. Teachers who have classes with mixed grade levels in their 7th period class.
Alright, so it's 3W squared over 4 when you reduce it down. I don't know how long this is going to go, so I'm just going to keep going. Here, there's nothing to factor. I'm just going to look to see what they have in common. So 3 goes into 6 twice. 8 goes into 16 twice. And then I'm going to look at the A's. Now we have a few things happening here. So maybe I'm going to do this first. So I'm going to multiply across the top and bottom and then reduce down again. You don't have to do it this way. So 2 times 2 is 4. And then when I multiply, I'm going to add the exponents. So I'm going to add, so that's the exponent 4, and add, that's the exponent 7. In the denominator, again, I'm going to multiply, so that's a to the 6. And then 3 and 1, that's b to the 4. So I have a 4 on top. Now if I look at the A's, the easiest way I think of this is how many more A's do you have in the denominator? So I have 2 more, so that's a squared. How many more B's do you have in the numerator? So you have 7 here and 4 here, so you have 3 more in the numerator, and you simplified it. Oh, and what can A, so both A and B can't be 0. So this is multivariable. I'm not going to give you a multivariable, but there it is. Neither A or B can be 0. That would make a 0 in the denominator. All right, step 1 here is to factor. So all of these are simple trinomials. So I'm okay with you doing this mentally. 2 numbers that multiply to negative 6 and add to 1 are positive 3 and negative 2. At some point mathematically, you're going to have to do some mental math. 2 numbers that multiply to negative 12 and add to negative 1 is negative 4 and positive 3. If you're not ready, you can draw your diamonds. Here, 2 numbers that multiply to negative 20 and add to 1, positive 5 and negative 4. And then the denominator, 2 numbers that multiply, and again, I'm not going to write this squared, is negative 2 and negative 2. But if I write it squared, it's harder to cross out. Now, I'm going to write down what the restrictions are. So it can't be positive 4, negative 3, positive and negative 2. Those are my restrictions. So anything on the bottom can cross out with on the top, but you can't have two of these crossing out 1. So only one crosses out 1. So I see x plus 3, so x minus 2 only crosses out 1, not both of them, and x minus 4. So what does that leave me in the numerator? X plus 5, and in the denominator, x minus 2. All right, number 5. So step 1 is we're going to factor this. This one has a little more steps to it because of the 2 and the 3 in front, but we can do it. So 2 times negative 5 and 9. So that's 10 and negative 1. And you have to divide by 2. So I'm going to write that in. So 10 divided by 2, that's 5. Here I'm going to slide the denominator in front, so that's 2x minus 1. I'm going to do the same thing here to the denominator. 3 times negative 10, negative 30 and 13, and those two numbers are what? 15 and negative 2. So when I go 15 and negative 2, I'm going to divide by 3. Make sure you see it. And 15 divided by 3, that's 5. 2 divided by 3 is a fraction, so that denominator is going to slide in front. Now, I'm going to change this from dividing to multiplying by doing the reciprocal. So the denominator is going to go on top. This is a difference of squares. Now, I have to square root to make this work. I can't do it the other way with a diamond. So I am going to square root 4, that's 2, and I'm going to square root 9m squared, that's 3m. Order matters here. So on the top is going to be 4 plus 3m and 4 subtract 3m. M? Why am I doing x's? M. Let's do m. What did I say 4? The square root of 4 is 2. Let's do that right. 2. And this should say 2. So both of those are 2. So 2 plus 3m and 2 subtract 3m. All right. Now, this is now in my denominator. So the biggest number that goes into both is 7. So that's 2m take away 1. Whew, we finally got through that. So what can m not equal? So look at the denominator, negative 5. Make the fraction again and make it positive, so it's 2 over 3. And 7 doesn't have a letter with it, just 7, so it can never be 0. So that's good, there's no restriction there. But here, move the 2 and it's positive 1/2. Now the easy part, I hope. M plus 5, 2m subtract 1. Now, we got to think through this. We have 3m subtract 2 and 2 subtract 3m. They're exactly opposite. In other words, positive 3m, negative 3m. Negative 2, positive 2. Those are called opposite factors. So when you cross them out, instead of being left with positive 1, because they're exactly opposite, you're left with negative 1. So I have negative 1, and you don't have to distribute, and I have 2 plus 3m. In the denominator, I have 7. All right, number 6. You got this. Again, some fun factoring here. So let's see if I don't run out of space here. I can do this. So a diamond, that's negative 60. So 4 times negative 15 is negative 60 and negative 7. So those numbers are negative 12 and 5. So I'm going to write p minus 12, p plus 5, and then divide by 4. And then come back. So 12 divided by 4 is 3. 5 divided by 4 can't divide, so the denominator slips in front, and it's 4p plus 5. That's the numerator. All right, the denominator, 2 times negative 27, that's negative 54, and 3. So that's 9 and negative 6. They multiply to negative 54 and add to 3. And again, I'm going to have to divide. So I have 9 and negative 6, and I'm going to divide by 2. So 9 divided by 2, the 2 goes in front, and that's 2p plus 9. Here, 6 divided by 2 is 3. That's p minus 3. All right, take a moment. We're going to change this to multiplying. I want you to see this as a fraction, that there's a 1 in the denominator. So I'm going to flip that and put a 1 on top and put 4p plus 5 on the bottom. So that's how I change it to multiplying. What can p not equal? I'll put that right here. P cannot equal. Make it back into a fraction again. That's negative 9 over 2, positive 3, and then again negative, make it into a fraction again, 5 over 4. And now our answer. So p minus 3, 4p plus 5. What's left in the numerator is 1, and in the denominator is 2p plus 9. Halfway there. Number 7. All right, we're adding and subtracting. The denominators are the same. So how simple is this? So we only subtract the numerators. So 2k subtract 1k is k. Negative 3. Now when you subtract a negative, you're adding. So it's negative 3 plus 11, which is 8. In the denominator is 3k plus 24. Now, pay attention. The denominator can be factored, and we can simplify this expression. So first of all, what can k not be? Let's factor it, and you can see. So if I factor out a 3, I have k plus 8, and that tells me what k can't equal, the opposite number. So k can't be negative 8. Then you can see k plus 8 simplifies, and you're left with 1/3. So even though it was simple at the beginning, at the end we still had something to finish. So if there's an ability to factor and keep going and fully simplify it, you must. And then you have what k can't equal. Same thing here, the denominators are the same. We're going to add. So 2x plus 3x is 5x. Negative 13 and negative 2 is negative 15. The denominator will stay the same, but then we're going to factor. So there we are, now factor. So we're going to factor out a 5. We're going to do a diamond. We have negative 36 and 9. And what are the two numbers that work here, which are 12 and negative 3? So we're going to write down 12 and negative 3. We're also going to write down what it can't be. So the restriction from the denominator is negative 12 and positive 3. Then we'll simplify it, and we're left with the answer 5 over x plus 12. All right, turn the page. All right, to add or subtract fractions, the denominators need to be the same. So for the first fraction, I'm going to multiply top and bottom times 5. For the second one, I'm going to multiply top and bottom times 3. So that gives me 5a over 15 minus 12, that's an a, over 15. And then 5a minus 12 over 15 can't be simplified. You need a number that would go into all three evenly. There's no restrictions here. So the denominator has no letters. So that means that those numbers would never be 0. They're technically not rational the way we think of them. All right, number 10, we're going to first factor. So the first one is prime. The second one, I'm going to do some work here on the left. So 3 times negative 15, let's try it again. 3 times negative 5 is negative 15, and negative 14 on the bottom. So the two numbers are negative 15 and 1. So I have m minus 15 and m plus 1, and then I'm going to divide. So I'm going to divide by 3. So when I do that, I have m minus 5, and then move the 3 in front, and you have 3m plus 1. So the two numbers m can't be are positive 5, and make it a fraction again, it'd be negative 1/3. Now these are almost the same. So what does the first fraction need that this one has is m minus 5. So we're going to multiply top and bottom by m minus 5 so the denominators match. So here I have 2m minus 10 and 19m plus 17, and I have one common denominator. And then I'm going to combine like terms. So 2 plus 19 is 21. Negative 10 plus 17 is 7. Now, if I factor out a 7, I get 3m plus 1. And they cross out and leave me with 7 over m minus 5. All right, 2 left. When we can't factor and they're both prime, we're going to multiply the denominators together. That gives me x times x minus 2. Then I'm going to take the bottom of one times the top of the other. The bottom of one times the top of the other. And that gives me x squared plus 5x minus 10. That is not factorable. And there's no like terms. The two numbers x cannot be here are 0 and positive 2. Those two numbers would make the denominator 0. And this is not factorable, it's prime, so I can't do anything else. All right, one more like that, number 12, and then we're done. So again, both of these are prime. You can't factor. So to make common denominators, we're going to multiply the denominators together. So it's n minus 6 and n plus 1. So we're going to take the bottom of one times the top of the other. That's 3, n plus 1. Subtract, same denominator. Now the bottom of one times the top of the other. Again, we're going to distribute, but I'll do that in the second step. So I want you to see the technique that I use there to be able to get common denominators. So that's 3n plus 3. Again, same denominator. We're going to write the restriction right now. 3n minus 18. Same denominator. So n cannot equal positive 6 and negative 1. All right, combine like terms. So 3n take away 3n is 0. There's no n's left. And when you subtract a negative, you're adding. So it's really 3 plus 18, which is 21. And then the same denominator. And you have your answer. All right, I'm super proud of you if you took your time, if you tried it first, if you checked your answers, if you're really trying to learn this and work hard. I know there's a lot of factoring and times tables, but I believe in you, and I'm really proud of you that you did your work. Mr. GMath, till next time.